that the astronauts read out.
Gravitational effect of those planets.
Hi, I'm Anastasia, and this is NASA Now.
Why do we go out into space? Why not just stay home and look around and learn what we can about our own planet?
Everything that we do in an engineering sense is directly applicable to other missions because the data that we collect is used to validate these mathematical models.
The fact that our rover is so big takes us one step further to learning how to design, build, and fly and land even bigger spacecraft that would be required to send humans to Mars one day.
This month, we've been focusing on the Mars Science Laboratory, also known as Curiosity. In this final program, we'll learn about the mission's impact on the future of space exploration. But first, here's what's happening at NASA Now.
NASA continues to push the boundaries of technology with the successful test of an inflatable heat shield. The Inflatable Re-Entry Vehicle Experiment, or IRVI-3, was launched from Wallop's flight facility on board a sounding rocket.
Beautiful view of the rocket.
Once the rocket reached its suborbital destination, the IRVI-3 and its payload were released to re-enter the Earth's atmosphere, reaching speeds of 7,600 miles per hour. The purpose of the test was to show that a space capsule can use an inflatable outer shell to slow and protect itself as it enters an atmosphere at hypersonic speed during planetary entry and descent, or as it returns to Earth with cargo from the International Space Station. Look forward to future test launches of even bigger inflatable aeroshells in the near future.
Curiosity is on Mars right now, exploring the red planet as it has never been explored before. It's looking into the past to answer some of the most fundamental questions about life and if it ever existed on Mars. Also, since the very beginning of its journey, Curiosity has been providing information that will help NASA experts in the design and development of future robotic and manned missions to Mars and beyond. On today's program, our Curiosity experts team up to explain the impact Curiosity will have on our future and the future of space exploration.
Why do we go out into space? Why not just stay home and look around and learn what we can about our own planet? They actually go together. What we learn in space comes back to how we see our home planet. And it's all about the science and the exploration. We go out into space to learn what we can about how are the planets formed. What is out there that can tell us more about our own planet. We explore to answer the big questions of where did we come from.
A lot of the reasons we do science is to answer just fundamental questions about the universe, even ourselves and our place in the universe. And you can't think of a bigger question other than, are we alone in this universe? So a lot of what NASA does is directed towards answering that question. Is there life on other planets?
Those questions are all based on the science. Those are our tools for how we find out where we came from and where we might be going. Some of that can be done by robots, which is what we're sending now. But eventually we'd like to send human explorers to reach out and touch other planets, asteroids, and places that we might live in person. All of that depends on knowledge, on how we can find out whether the Earth and the other planets near us share things in common. We do that by setting science objectives and taking instruments that help us answer those questions. So we set our questions, we figure out what we need from an engineering perspective to answer those questions, and then we build and test the missions that will go out and bring us back those answers.
3, 2, 1. Main engine start. 0. And liftoff of the Atlas V with Curiosity.
This type of architecture, this type of system design would also need to be used for a future human mission to the surface of Mars. We're flying the biggest parachute ever, we're having the most capable heat shield ever, and we're having the most capable terminal descent system with these 8 main landing engines. And another wonderful feature we have about our EDL system is we actually have a bunch of sensors on our heat shield and on our back shell. We can then take those sensor measurements and put them into a computer simulation, which then we can use on a whole variety of different entry vehicle designs in the future. So this could be for future robotic Mars missions or for future human landed missions to the surface of Mars. So everything that we do in an engineering sense is directly applicable to other missions because the data that we collect is used to validate these mathematical models, and then those mathematical models can be applied to future designs.
One of the things we'd really love to do, and maybe people younger than me like yourselves will be the ones to get the chance to do it, is to actually go to Mars. And we've been working towards that goal by sending and learning how really to send bigger and bigger, more capable spacecraft to Mars. So the fact that our rover is so big takes us one step further to learning how to design, build, and fly and land even bigger spacecraft that would be required to send humans to Mars one day.
NASA has a mission to communicate to the next generation of students and of explorers that there will always be another hill to go over. There's another thing to see, another thing to explore. We will always need explorers, whether they are artists or poets or mathematicians or scientists. There's a whole universe out there. And it is our hope that these missions are the beginning of an ongoing journey.
How would you like to help explore the universe one day? You can make NASA a goal in your life in the same way our guests did way back when they were your age. What an exciting journey. Here's an activity that gives you the resources to design a mission to Mars.
Teachers, your students can take the roles of systems engineers in this activity where they design a realistic mission to Mars. For more information about this challenging lesson, look for the Mars-bound link on the NASA Explorer School's virtual campus.
Well, that's it for this special Mars edition of NASA Now. Be sure to visit our Facebook page and tell us about the part you plan to play in the future of space exploration. Dream big. See you next time on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.